everyone. My name is Esther. I'm a PhD student at Lancaster University in the United Kingdom. And the title of my research, as you can see, is Topology-dependence of propagation mechanisms in the production network. At first, I'm going to talk about the background of my research, then I move on to the methodology and of the results, and in the end, I will present my conclusions. No industry can exist and grow in isolation. All industries are interdependent through the exchange of goods and services. This basic concept is so clear that practical people have used it since forever. So for example, if a car mechanic knows that he needs 5 wheels and 5 tires, he balances his production plans accordingly. So he doesn't know that he's using the input-output analysis, what I also used in my research. This is an economic model which specifies what inputs are required for industries from other industries' outputs. So they show the monetary transactions between industries. These models can be transformed into simple production networks. So the nodes in the network are the different industries, and the links between them are the monetary transactions. So the nominal flow of goods between sectors. The production network, of course, is a directed network because if A industry needs B, the relationship might be the same the other way around. So it matters who is supplier to whom, and also the weight of each relationship is the economic value, which indicated the extent to which one industry supports the operation of another one. So researchers agree that production networks can be a bridge between micro and macro analysis, and they can shed light on industry co-movements and on the propagation mechanisms behind aggregate outcomes. So this is an example of the United States input-output accounts showing a fragment of the ego network of the storage battery manufacturing industry. It is clear that there are 2 dimensions. The first one is the incoming links perspective, and the second one is the the other way around. The first one is the outgoing links, and the second one is the incoming links perspective. So both dimensions are present in a production network, and the way it shows how many dollars is required for one industry to produce $1 of output from another industry. So this is also normalized. If we talk about propagation mechanisms, then it's very important that the structure of the network. So let's just compare 3 different national economies. One economy with one horizontal economy with no input trade, a second one, a vertical one with one source and one target, and a third one, a star economy with one central node. So if we just intuitively compare these and we ask ourselves where the amplification of micro level volatility is the most significant, well, we can intuitively say that it is in the star economy. So this was the model of the production network. And with each, there is a problem with the production networks because with each small flow of money taken into consideration, these networks are very dense and they are almost like a fully connected graph. So if you want to analyze a network of 100 industries, there are almost 100 square connections between them because most industries have monetary transactions between them down on their supply chain somewhere. Of course, with different amount, but there is. So most researchers use a threshold and they take into account a percentage of the monetary transactions, say 50% of highest in value. So that's a problem because we don't know that how much this distorts the whole picture. So we can agree that it provides a bridge between micro and macro level volatility, but we know very little about how much bridge is distorted. So our research question was to find out to what extent this threshold changes the structure of the network, hence the propagation mechanisms. We use the United States input-output accounts. It has 3 levels of data, and we use the most detailed one with 400 subsectors. And after building the production network, we defined 100 threshold and we checked the topology of the network at each threshold. So for example, when the threshold was 0.5, we included only those monetary transactions where $0.50 was needed from one industry to another one, at least $0.50 to produce $1 of output for the final consumers. And this was a very extreme threshold, and only the most important connections were present. So at each point, the topology of, we compared the topology of the network with two very popular network structures. So if it was more similar to a random network, that would mean for our production network that most industries need the same amount of resource and supply the same amount of resource. If it was more like a scale-free, that would mean for our production network that would be similar to a scale-free topology, and there are industries which lead the way and are the engines of the national economy. So this is the network at 0.1 threshold, where $0.1 was needed from one industry to another one. And this is also a very high threshold, because you can see that from 400 nodes, there are just several present. So this concludes mostly the discovery of the research, that here we analyze the network structure at each threshold. The horizontal axis is the threshold, and the vertical axis is the statistical test value. The less is the value, the more similar to that structure is the production network. The yellow being the random one, and the blue the scale-free. So there are four figures, because the top is the 2007 data and the down is the 2012. And the first ones are the in-degree perspective, and the second one the out-degree one. So two important conclusions can be drawn from this quite complicated figure. First, we can see that the topology is quite volatile to the threshold value. So as we disregard more and more monetary transactions, the topology changes more and more. And the other one, that it even goes to a topology shift. So not just it fluctuates in the scale-free and random range, but it goes from scale-free to random, which is also a very important conclusion. So you could see that there is an asymmetry in in-degree and out-degree. So if we compare how they would relate, we see the asymmetry, because this is a directed network, and the in-degree means that how many supplier do they need and how many resource do they need, and the out-degree that how many they pump into the production network. And the asymmetry is quite clear, because we know from economy that there are industries which are the engines of the economy. So these called like commanding heights are the key segments of the national economy, and these are the industries that push the topology to the scale-free direction. So it's like saying if you have oil, gas, petroleum, you have everything. And this is what this figure exactly shows, that the top industries according to threshold. The horizontal axis is the threshold value. So, and as we disregard more and more monetary transactions, the top industries change. So the first industries, as I said, they are the iron, oil, gas, and petroleum. And as lower value transactions have been cut due to threshold, some industries that are at the top of the rankings have fallen. So you can see the green one and the blue one. This is the truck transportation and utilities. These were generally the industries that supported almost all the others, but with smaller value transactions, such as truck transportation, of course, and utilities. And this suggests that the threshold used by researchers cuts out some significant central nodes that amplify aggregate fluctuations. So another issue with the production network studies is that there are just only a few studies that develop a network of at least 400 subsectors. So it is quite different to model something in a 30-sector network and in a 400 subsector network. So you can hardly model any impact at that level. So this figure compares two levels of detail. So we show on this figure that the subsector and the industrial level, how do they relate? Both are the leading industries in the production network. Firstly, by weighted out degree. which indicates that how important the industry is in monetary terms, and by patron out degree centrality, which tells us how important is by location that industry. So some aggregated industrial categories have only one subsector in the top list, such as you can see mining, management of companies and enterprises, while others have several, such as non-durable goods, wholesale trade, and this distorts the analysis of production network. While on the other hand, the grouping of industries into categories is rather arbitrary, because so when analyzing super industries, it might be questionable which level of detail is used to construct the production network. So, and this moves us to the conclusion. So we analyzed production networks, and our hypothesis was that the changing the percentage of monetary transactions that researchers count into the network, the edge threshold, will change the structure of the network and the underlying industries to a large extent. And this was important because if the structure of the production network changes and it's not well defined, the internal propagation mechanisms will change too. And thus the modeling of industry growth or modeling of every shock, every micro shock. So one of the main discoveries in this research is that even small supporting transactions can make a difference. So although we could cut out all truck transportation, transactions, a disruption in this industry would have a big impact on the other sectors. So if there's a disruption, some manufacturing sectors will be disrupted too, because, for example, some spare parts are unlikely to arrive. So if we ignore these transactions, we lose some important mechanisms, and they don't have just a direct role because they also function as intermediaries. So if we cut them, we ignore all the propagation mechanisms along the chain. And yes, that's what we wanted to show with this study, that this threshold makes a significant difference. So we should keep in mind the limitations of the research made on these production networks and carefully consider this threshold. Thank you very much.